Okay, here's a seemingly interesting question where we're being told to say we have an helicopter which is traveling at a speed of 70 meters per second, and it is 200 meters above the mountain where the climbers are, and its task is to drop supplies to these climbers. And there's a guy in the helicopter who throws these packages 400 meters to the climbers, and they drops these packages in advance. And we're told to say this helicopter is traveling at a speed of 70 meters per second. Okay, so now here's the interesting part about this question. When this guy in the helicopter throws the packages, we don't know whether he will add to this speed at which the helicopter is moving. We don't know whether he will add as the package is falling, or we will subtract to this speed. Adding means he will throw it at a speed which is greater than the speed at which the helicopter is traveling. Subtracting means you will throw it at a slower speed, hence slowing down the package, and we will have a lesser speed at which the package is traveling. Okay, so we need to find the speed at which this guy is supposed to throw this package in order for the package to precisely land at the position where the mountain climbers are. Right. So we've been told that the vertical position is 200 meters above the mountain where the climbers are. Okay, this that would be very helpful. So we can't use the horizontal components when we are solving this question, mainly because we don't know whether we are adding to this speed or subtracting, as I explained when this person throws these packages. Okay, but we can use the vertical part of this question, because we know that if this person in the helicopter is throwing these packages horizontally, we know that the the vertical velocity as he is throwing these packages, which is uy, is going to be equal to 0, because he's throwing them horizontally. Okay, and we have been given the vertical displacement to reach the mountain, which will denote by s. This s is equal to 200 meters. We know that g is equal to 9.8. So now, which formulas can we employ to find we need to find the time taken for this package to drop a period of to drop a distance of 200 meters. Why are we finding the time? We are finding the time mainly because the time taken in the vertical is also equal to the time taken in the horizontal. That's why we are finding the time. So we can look at two formulas that can help us. There is this one, S is equal to U, Y in this case, T plus G T squared, 1 over left out 1 over 2. Okay, and we have this formula U V is equal to U plus GT. Now, which one of the two will help us? Let's look at which one has the least unknown values. Okay, if we look at this one, it's not going to be useful because we don't have the final velocity as the package reaches the mountain climbers. We do have the initial velocity to be equal to 0, but we also don't have the time taken, which we are trying to find. So this one has two unknowns. Therefore, it's not going to be useful. But if you look at this one just has one unknown, which is the time. Okay, so replacing the things that we already know into the first equation, we know that S is equal to 200. Okay, let me drop the meters. S is equal to 200 and y is equal to 0. So I'm not going to write it. We're just going to have 1 over 2. Our G is 9.8 and our T is what we're trying to find. Rewriting this, we find that we're going to have T be equal to the square root of 400 over 9.8. That's going to be our value of T, 8. Simplifying this, we're going to get 6.39 seconds as our total time of flight. Okay, now let's find the speed of the package relative. Let's find the speed of the package relative to the ground. At what speed is this package moving? Okay, for us to do that, we'll go into the horizontal now, since we have the time. Since we have the time of what? We have the time of flight for the package. So we know that our x, which is the range or the horizontal displacement, is equal to Vx t. What we're trying to find is this Vx, because we know x is equal to the 400 and t, well, we just calculated t. So now we're writing this equation, we're going to get Vx to be equal to x over t, and our x is 400. Dividing this 400 by 6.39. Once we do that, we're getting a value of 62.6 meters second. So we discover that the speed relative to the ground is 62.6 meters per second. That means that as this guy in the helicopter throws the package, is slowing the package down for us to get a value lower than 70. So what does this mean? This means that it's not throwing the package in the positive x direction. It's not throwing the package forward, rather is throwing the package backwards. And that is how we're getting a lower speed relative to the ground. So this speed that we are finding, that we have found, 62.6 meters per second, is relative to the ground. Now we need to find the speed relative to the helicopter, and for us to do that, we find that the speed relative to the helicopter, as this guy is throwing this package backwards, is going to be equal to 70. Actually is supposed to be 62.6 minus 70, which is giving us negative 7.4 meters per second. But what this negative just indicates is that this guy is throwing this package backwards instead of forward. So he's throwing the package backwards. Yeah. All right. So in short, what we're saying is that 7.4 meters per second is the speed of the package relative to the ground. Oh, sorry, not relative to the ground. Say relative to the helicopter. And that's how you go about solving this question.